Who needs math to begin with? In a book called Science Without Numbers in 1980, a scientist called Field, he showed that as an example, you can he showed that some fragment, some piece of Newtonian mechanics could be nominalized. And by nominalized, I mean does not involve the mathematical entities and the numbers and the things that we are used to. You can talk about masses and accelerations and forces and all that stuff without invoking math. And how did he do that? The method is very simple. It just requires a little bit of knowledge of what numbers really are. Numbers are constructions in the mathematical theory. They are not born from outer space. If you believe that numbers reflect reality, if you remember the episode we did on math, the nature of mathematical objects, we had a position called Platonism, which believes that these objects are a reflection of some perfection idea that we have, that lives in the world of forms for Plato. We had another opinion or another school, which is the realist school, and that school claims that mathematics is a reflection of reality. It comes from reality. No? And so if you believe that, then of course you cannot change the numbers. Of course you cannot touch the system and its axioms. Of course you can't. As long as you haven't made any discoveries in the real world out there that change your conception of the world, in which case you change them, of course. But the other understanding, which is that mathematics is a construction, the formalist understanding, has no problem in changing things because they know that this is just a game like chess. And you can change the rules of chess whenever you want. And so as long as you walk with him on that assumption, what he did, again, without going into the mathematical details, is that instead of defining mass is a number like that, so mass is a real number, and it inherits the properties, for example, that if M1 is less than M2, then there exists an M3 such that, for example, M1 is less than M3, and then it's less than M2. You can always squeeze a number between two others, for example. Or you can always, I don't know, if a number is equal, if A is equal to B and A is equal to C, then B and C are also equal to each other. Or A times B into C plus D, then you can distribute multiplication, or you can factorize some. So all these axioms of numbers, as you define mass, you say mass is a number, it inherits all those properties of numbers. It inherits all those behaviors, quote unquote, if I may use the word. So instead of doing that, you define a mass as having these properties, without mentioning numbers altogether, without using mathematics, you say whenever you have a mass equal to another mass, and then a third mass equal to both, then the first and the second are equal. Whenever you have a mass bigger than another mass, you can always find a third mass that is less than the first but bigger than the second. And now when I phrase it that way, I'm not saying anything that is not observable, quote unquote, because if you believe that masses are tangible, physical entities that are part of our ontology, then all I'm making, when I phrase my claims in that language, all I'm saying is go look out there in the world for that mass. You can go find it. If you have a mass and you add it to another mass, then you make a third mass. Go find that third mass that is equivalent to both. And then you say, oh, how do you define equivalence? So instead of equality, how do you define equivalence? Well, we define it a very physical way, and we're going to have another episode about definitions in physics. We call it an operational definition, the term used by Percy Bridgman, the physicist. So you define it very physically. You say, oh, I put it on the scale and it gives the same value. Or I put them on those balances that rock up and down, the Roverbier, they call them, Roverber, I forgot. The very old ones that balance, right? And then you put the first one on the left and the second one on the second hand on the right, and they balance completely, they are leveled, the balance is leveled. That's what we call equivalence or equality now. We don't need any mathematical axioms, we don't need any theoretical terms, we don't need anything.